Hello everyone, Chris Droha. This is the lesson on seasons and moon phases. So I want you to look at this statement. When the sun is blank, it is summer. And when the sun is blank, it is winter. So what would you fill in the blanks there? Some people might say when it is hotter, it's summer. When it's colder, it's winter. But the sun doesn't really change temperature. How about this one? When the sun is closer, it's summer. When the sun is farther away, it's winter. Actually, that one's not correct either. We're actually closer in the winter in the northern hemisphere. So let's look at this picture of the Earth going around the sun. Notice that it actually is an ellipse where the sun is a focus. So it is closer, the Earth is closer to the sun in January by about 500 kilometers compared to July. It's farther away. So that's about a 3.5% change, which isn't a whole lot. But it does kind of shake things up because a lot of people think that, well, when it's closer, that's summer. But it has nothing to do with how close we are to the sun. So notice that in June, there's a couple of words I want to point out here. Solstice is one of them. So we have the December solstice and the June solstice. Those are the longest and shortest days of sunlight in the year. In the northern hemisphere, June is the longest and December is the shortest. Now, equinox in March and September, those are when the days are equal distant for both the north and the southern hemisphere. So here's another picture. This is from a sideways like we were talking about. Here's the sun, obviously not drawn to scale. We have in June, notice the Earth is actually tilted. And so many of you probably know that, but it's tilted at a 23.5-degree angle. So in June, the northern part of the Earth is tilted towards the sun, and in December, the north is tilted away from the sun. March and September, those are those equinoxes where even though the Earth is tilted either towards us into the screen or away. So it's not affecting the seasons like we're about ready to talk about. So here's another picture. I thought this was interesting. This is from a top down. And the thing that's interesting about this is we have this little circle, the Arctic Circle, actually, right here. And in June, because the Earth is rotating around that yellow dot, the Arctic Circle stays in sunlight the entire day. And in December, it's in darkness the entire day. Okay. So here's one more picture. We have the Earth, again, that 23.5-degree angle in the two equinoxes. And here we have, again, the June solstice and the December solstice, where they're angled towards and away. Now, of course, if you're in the southern hemisphere, then it's exactly the opposite. The southern hemisphere is tilted away during June and towards during December. So that's why the seasons are flipped for the north and the south. So what does this have to do with seasons? Well, why does it get hotter? Here on the left, we have the sun higher up in the sky and providing more direct sunlight onto the ground and onto the Earth that's pointing towards it. Versus when you're pointing away, the sun's lower in the sky, we're getting an angle, more of an angle there. And you can actually try this yourself. Get a light bulb or maybe a candle. Be careful not to get too close to it, but if you have that light bulb here and you put your hand flat against it or above it, it's going to get hot and feel really warm. Now just don't move your hand closer or farther away, just tilt it a little bit, and you're going to find that you're going to feel it's going to be cooler. That energy is getting spread out over a longer distance. So let's talk, since we're talking about some of the different days of the month, or the different months, let's talk about the calendar. We actually use a Gregorian calendar, which is counting the days that it takes to go around the sun, 365 days. Actually, it's 365 days and 1/4 of a day. So we usually don't celebrate that 1/4 of a day. We just add them up, and once every 4 years, we have a leap day. So February 29th. There's another way that you could measure that, and there are some cultures that do this not based on how long it takes to go around the sun, but but the phases of the moon and the period of the moon it takes to go around the Earth. So the moon phases have a period of 29.5 days. And so there are some cultures, the Islamic calendar, for instance, is based on it's a lunar calendar. So they take 12 months and multiply it by 29.5 days to get a year of 354 days as compared to the 365 days of the solar calendar. There are some combinations of those, the Chinese calendar and the Hebrew calendar, those combine the two ideas together. So let's talk about the moon phases. The moon phases are these down here. So this is a great image of this. If the sun is here on the right side, moving, going from right to left, you see the Earth is bright on the side towards the sun and dark on the side away from the sun. That's the same as the moon. The moon's going around the Earth, and notice that at any point around this entire circle, the moon has 50% of it is lit, the part that's towards the sun, and the other side is dark, just like the Earth. Now, if we're on the Earth looking towards the moon, then we're going to see different things. We're going to see maybe it dark or completely bright, or in some cases, part of that. So if I'm on the Earth here and I'm looking towards the moon, this is called a new moon. I'm only seeing the dark part of the moon. The sunlit side is pointing away from the Earth, so I don't see it. So this is called a new moon. Notice that we're going to see this more often in the daytime. It's actually really hard to see a new moon because it rises and sets about the same time that the sun does. As we move around the circle, now again we're only seeing just this light part here on the right side. That's called the crescent. And because the brighter part is getting bigger, we have this word waxing. It is a waxing crescent that's getting bigger. So here we have a first quarter moon, a waxing gibbous. So a gibbous is in between half and a full moon. And notice it's interesting that some people think that the phases of the moon is caused by the shadow of the Earth, but there's no way that a round Earth can cast a shadow like that to create a gibbous moon. Here we would be on the Earth and we'd look and we would see the full moon. And now that as it goes back towards a new moon, we start getting some more darkness. We have a gibbous. But because the bright part is getting smaller, we're saying it's waning. Waning gibbous, a third quarter moon, and a waning crescent here on this side. So if you notice the waxing and in the first quarter here, the bright part is on the right. I'm going to draw a line right down like this. And as you go around, the bright part, as it's waning, the bright part is on the left. One of the ways I remember this is with this line, this is like a lowercase b, and this is a lowercase d. And so I'll use this, I'll remember this, that it's getting bigger at this point, so it's waxing, B for bigger, and D is decreasing or diminishing, if you'd like. Okay. So when a new moon occurs, what's the phase of the Earth? If you were standing on the moon, what would the Earth look like? It would be a full Earth. On a new moon, it would be a full Earth. Let's go back and look at that real quick. If I was standing on the moon at night, on a new moon at night, and I looked back at the Earth, it would look like a full Earth, completely bright. But if I was standing on the moon when it was a full moon, I would see a completely dark Earth or a new Earth. So what we find out is that the Earth is always in the opposite phase to the moon as the moon is to the Earth. Let's talk about the moon's orbit real quick. The orbital period around the Earth is 27.3 days. That's how long it takes for the moon to go from all the way around the Earth. It's 27.3 days. But the period of the lunar phases from new moon back to new moon again is 29.5 days. So what's going on with the difference? Why is there 2.2 extra days there? Well, if we look at this and we go around, At this point, we've gone from here all the way around, and we've covered the entire Earth. But because the Earth is actually moved around the sun, it has to go a little bit extra before it reaches that new moon point again. Here's another interesting thing, and something you should maybe look up at some point. But the spin of the moon, how much it's rotating on its own axis, and the rotational period of the moon around the Earth are exactly the same orbital period, which means that as the moon is rotating around the Earth, it's rotating itself, and we always see the same side of the moon, exactly the same side the whole time. Well, interestingly, we at any given point we're only looking at 50% of the moon, but because the moon wiggles a little bit, libration is what they call it, we actually see a total of 59% of the moon over the course of the month. So here's a quick video of that. So this is pretty cool, actually. And if on this video, sometimes I like to slow it down a little bit so I can judge it. So we're going to start here. We have a new moon. We're going to start at the new moon. Notice up here in the upper left, it's pointing towards the bright part of the Earth is pointing towards the moon there. And as it starts to go around, we're going to have our waxing crescent. Here's our first quarter moon. There's the first quarter. Looking up here. I'm going to remove the waxing gibbous. Again, this is the part of that the sunlight is on that we can see. The Earth is not casting this shadow to make this happen. And as it goes around, now notice though, we're seeing the same side of the moon the whole time, which is really amazing. Down here in the bottom left, it shows you the angle, how much the moon rotates from our perspective at any given point. All right. So one last thing about the moon's orbit, and this is going to get us into our next video, which is going to be on eclipses. The moon's orbit is actually tilted at 5-degree angle. If it was not tilted at a 5-degree angle, we would get a solar and a lunar eclipse every single month. But because it is tilted at a 5-degree angle, as the Earth goes around this light blue circle, the moon is going at a slight angle, so that, notice here, the shadow from the moon does not actually run into the Earth most of the time. Okay, we'll see you with the next video.